Hi everyone. In this video, I'll show you how to simulate the Santronics problem in Excel. This is a good example of how you simulate discrete distributions, uniform distributions, and normal distributions using Excel. These are the discrete, uniform, and normal distributions that I talked about in the previous video. If you haven't watched the previous video, I strongly suggest that you do. It gives you the basics, and then in this video, we'll see how you simulate this in Excel, right? So for each of these trials, we'll generate three separate random numbers. I'm going to call them random number 1, random number 2, random number 3, three separate random numbers. And using each of these random numbers, we're going to simulate one value for labor cost, one value for parts cost, one value for demand, and then calculate profit using these three numbers, right? Okay, so let's begin with labor cost. So labor cost is a discrete distribution, and as we know, with discrete distributions, what we are going to do is this. So the way we simulate a discrete distribution is we generate these values of random numbers. So we have intervals of random numbers between 0 and 1, and then we use those intervals to simulate the discrete distribution. Now, in Excel, when doing this, we don't need to generate the upper ends of the limit, upper ends of the interval. We just only need to know the lower end of the interval. So 0, 0.1, 0.3, 0.7, and 0.9. So as long as we don't know these numbers, we know the everything about the intervals because it is 0 to 0.1. Then this is the same as that, 0.1 to 0.3, then 0.3 to 0.7, then 0.7 to 0.9. So as long as we know the lower values for the interval, we know what the intervals are. And that's exactly how Excel does it using the VLOOKUP formula. So what we'll do is we'll generate the lower limit, I guess, lower bound for the interval. So we'll calculate the lower bound for the interval. Let me make this part of the table. So the lower bound for the interval, you'll notice that it will always begin at 0. The first value for lower bound is always going to be 0, and then it will be based off of the probability values. So the simplest way to do this is you always begin the lower bound at 0. I'm sorry. And then the second one will be the previous lower bound plus the probability for the previous value, right? And then I'm just going to copy the same formula all the way down. So this will be the previous lower bound plus the corresponding probability, previous lower bound plus the corresponding probability, and so on. So we'll end up with all the lower limit values. So if you notice 0, 0.01, 0.03, 0.07, and 0.09, they are the same as 0. Oh, I'm sorry. It's just 0.1. I don't know why I wrote 0.01. I'm so sorry about that. It should be 0.1, 0.2, 0.4, 0.2, and 0.1. There you go. Right. So those are the values here. I guess we don't need two decimal places. Just do it one. So those are the lower bound values. So once we have the lower bound values, we can now generate the labor cost. So the way you do that is you first generate a random number. So by using the rand formula, equal to rand, that's all you have to do. We first generate the random number. There are too many decimals here. We are not removing the decimals, we're just showing 4 decimals. It's easier on the eye. That's why I'm just showing 4 decimals. In fact, even 2 is fine. Then the labor cost will be, the formula for that is VLOOKUP. So V is because it's a vertical lookup. You can also have a function called HLOOKUP, which is a horizontal lookup, but we'll be using the VLOOKUP. So if you notice, there are all of these values that we need, and any value that is within these square brackets here, you don't need to input in the formula. So for this formula, we'll be inputting these 3 numbers. The lookup value is the random number that we generated. That's the lookup value, comma. Next is the table array. So the table array will include the lower bound values and the values of the random variables. But because we'll always be referring to the same numbers, I'm going to make these absolute references, right? So A3 to A7. So that's the lower bound values and the values for the random variables. A3 to A7 all in dollar signs. The lookup value is not in with dollar signs. Then comma, column index number. This is 2. And the reason why we say 2 here is because in this table, there are 2 columns, one with lower bound value and lower bound, the second with value, and the value that we want generated is in the second column, right? So we have comma 2. And there you go. That's it. So that's a simple formula to generate this. So what this is going to do is generate a random number, then look up which range it is in, and based upon the range, it will generate the corresponding value of the direct labor cost, right? There you go. Okay. So it's 0.35. So it is more than 0.3, but less than 0.7. So it generated 0.45, which is the labor cost. Okay, that's a dollar value. We make that a dollar value, right? Okay, now we generate another random number here. This is also going to be a random number, so let's just write the random formulas. You know what, 2 decimal places is too few. Let me show 4. There you go. Now, parts cost. So parts cost is uniform distribution. Uniform distribution is simple, as we saw with the formula. It is the lower limit plus the difference between upper and lower limit times the random number, right? So it's going to be lower limit plus, or I mean, I like to start the formula the other way around, but either way is fine. So it's lower limit plus, don't forget the parenthesis, the difference between the lower and upper limit, which is, you can do 100 minus 80 like that, or you can just type in the 20. That's fine. It just makes your life easy. So 80 plus 20 times the random number we generated, right? Right. So whenever you refer to the random number in whichever formula we're using, you'll notice that we never use dollar signs because they're going to change with each trial. Finally, demand. For demand, the formula was norm.inv. So if you notice, the formula was norm.inv with the random number. Mean is 15,000, standard deviation is 4,500. Mean is 15,000, standard deviation is 4,500. So this is the random number we generated, comma mean, which is 15,000. So standard deviation is 4,500. I'm just going to type in the numbers because there are only 2 of them. But if you want, you can just refer back to them. So if you're referring to them here, make sure that you use dollar signs for these because they're going to stay the same for the whole value. So that's my demand. But the only other problem with demand is that if you look at demand sometimes turns out to be a decimal, and that is not okay, right? So demand for some item that you're making cannot be 81.35. So it has to be a whole number. So one thing we can do is we can surround the formula with the round function. So what the round function does is it rounds a number, so to a certain number of digits. So it will be round this formula. So this will generate the demand value. I want this rounded to 0 decimal places. So its round is on the outside. We generate whatever normal from the normal distribution. We generate that number. Then we're going to round that to 0 decimal places. And there you go. So that's my demand value. So with that, now I can calculate profit. So the profit value is 249. So if you remember, the formula for profit was right here, 249 minus the labor cost minus the parts cost. All of this times the demand minus the fixed cost, which is $1 million. So it's 249 minus the labor cost minus the parts cost, right? Times the demand, yeah, minus $1 million. I'm going to do some housekeeping. Parts cost is also dollar value, labor is dollars automatically. Okay, good. So that's my total profit for this particular scenario. Right, so this is one trial. So whenever we are doing this, we don't use a single trial, we use multiple trials, right? So let me just copy this formula down once. So just copying the formula down, just copy everything over. And this, I want to do 1,000 simulations, so I'm going to go all the way down. That's a little bit more than what I want to do. Let me bring it down to 1,000. Come on, don't be shy. Ugh, going too fast. There you go. 1,000 simulations exactly. So that's 1,000 simulations, and you'll notice that some of these profit values are negative, so we are making a loss sometimes. So there is a possibility for loss, and that is one of the biggest reasons why we are doing this, figuring out the probability for loss, right? So we have the profit value. So this is how you simulate a discrete distribution, this is how you simulate a uniform distribution, and this is how you simulate a normal distribution. So I know that I've gone over the 10-minute mark, but I'm just going to spend a couple of minutes. There are two important things that you want to calculate here. One is the average profit. The second one is the probability of loss. How likely is it that you'll end up with a loss? So these are two big important numbers that you want to calculate, and let's calculate that. So average profit. So now there's one trick that I'm going to do. We have a lot of simulations, so I'm just going to hide oops, let me get out of this. So just going to hide a lot of these rows. So you'll notice that from here onwards, I'm just going to hide a lot of these rows, go all the way down, almost over there. Okay, let's show maybe, that's fine. I'm going to right click all of these rows and click on hide. Right. So this way, I have all of these simulations, they're still there, but they're just hidden. So when I write these formulas, it's easier. Let's say the average values, because I want to find the average profit of all of these numbers. Now, because I have hidden these rows, when I choose this, it'll choose all the rows, including the hidden ones. And that's my average profit, $720,000 on an average. And then the probability of loss. Now, this is an important piece. So the probability of loss, I want to look at all of the profit values. So I've generated 1,000 profit values, right? So I'm going to look at all of these 1,000 profit values and count how many times in these 1,000 times did I end up with a loss. And that is going to give me a probability for loss. So I'm going to count that, then divide that by 1,000 because I did 1,000 trials. So I'm going to get the probability of loss. I'm going to say count if, so only count. So I'm going to do count if. So all of these values, so this is the range of numbers. So count within this range. And then it says criteria. So how do you want, what is the criteria? So I only want to count the numbers that are less than 0. Now, you see I'm putting less than 0 in quotations. Do not forget the quotations. If you don't use the quotations, you'll end up with the wrong answer. So you have to say less than 0 in quotations. So of all of these values, you're trying to figure out how likely is it that you'll make a loss, right? So this is not the full formula just yet. So this says that out of the 1,000 times that I did simulations, 97 of those simulations had a loss, but I'm not just counting the number of losses. I want to find the probability of loss, which is divide by 1,000 because we did 1,000 simulations. So out of these 1,000 simulations, how many times did I have a loss? That'll give me an approximate idea of probability. And here you go. So, okay, this is not dollar. This is actually just a percentage. Let me show a couple of decimals, right? Now, one thing you can do in Excel is if you press F9, the function, the function 9 key on top of your keyboard, it recalculates all the formulas on the Excel sheet and it'll generate different values for random numbers. And you'll notice that the loss probability is changing. So you'll notice that in many of these cases, it's gone down to something like 6 point something sometimes, and it's gone up to 10 point something. So you could say something between 6 and 11 is the approximate probability. So there's a chance of making losses between 6 and 11%. And that's something that you can figure out. In a similar vein, if I want to find what is the probability of making less than, say, 100,000. So less than 500,000. Let's say I don't want to make less than 500,000. What is the probability of making less than 500,000? Let me quickly. What is the probability of making less than 500,000? So I'm just going to use the count if formula again. I'm going to count if in the same range. how many of these are less than 500,000, right? So again, I did the same thing. Instead of saying less than 0, which counts the probability of getting a loss, we're trying to find out what is the probability of making less than 500,000. Because maybe sometimes making less than 500,000 might not be worth it based upon the amount of time that you invest in it. So what is the probability of making less than 500,000? That's the probability there. You can also calculate the probability of, say, making more than $1 million. So you would just say greater than 1 million or something like that. And all of this divided by 1,000 because we're doing 1,000 simulations. And there you go. So there's a 33% chance that we will make less than 500,000. So that's 1 in 3 chance of making less than 1 million. So if you look at the different values, it ranges, and also it gone down to 29 sometimes, goes up to 36 sometimes. So you can say between 29 and 37% chance that you will make less than 500,000. That's almost 40% chance. So that's something that you have to keep in mind before you get into this business, right? So again, this video has gone way too long. So in this video, we saw how to simulate discrete distributions, uniform distributions, and normal distributions in Excel. And then we looked at some simple ways of gathering data from all these simulations that we ended up doing. All right. Okay. Take care.